quick run through on even versus odd functions. When you're looking and describing the characteristics, a function can be even or odd, and it doesn't mean necessarily the power of the function. There are some propensities. You know, if it is even, it tends to have an even highest power. However, not all even powers are even functions. In order to be an even function, the domain, every value that you plug in, positive versus negative. So if I plug in 2 and negative 2, the output will be the same. So think parabola. If I plug in 2 or negative 2, it is symmetric. They have the same outputs going up. As we move out to the left and the right equally spaced, the outputs are the same. That's what makes it an even function. If you move away from the y-axis, it's no longer an even function. It has to be symmetric around the y-axis. If you take that same parabola and you shift it to the left, and now it's over here, now the x values don't match anymore. 2 and negative 2 have two different outputs. This one's way up here, this one's way down here. So it's no longer an even function. And we'll study later that even functions and odd functions have some pretty cool traits and patterns. Okay? Let me see if I can erase this all at once. I'm going to get Corey. Oh, nope, maybe not. Nope, I give up. Odd functions. Odd functions have a pattern of their own, a little bit different. So I want you to think cubic functions as your reference. So let's see, even we think parabola because of that symmetry. Odd, I want you to think cubic. An odd function, a cubic function looks something like this. As you enter the x value, the positive and the negative, so think 3 and negative 3. The outputs are no longer the same, they are opposite of each other. So the output of the positive might be, let's say 27. But on this one, it would be negative 27. The intrinsic value, the absolute value or distance is the same, but you're traveling in opposite directions. So for this, if you think about it, if you go over and up, this distance here is the same as if you go to the left, the same amount, and down. Those distances are the same, but they're in opposite direction. Again, it is symmetric. This time it is symmetric with respect to the origin. Because from the origin, you're going in opposite directions and opposite directions vertically as well. Even versus odd. So in class, we'll look at some graphs of functions and decide yay or nay, even versus odd. We'll review this in class. The end.